Okay, before we get started, I want to quickly ask something. Who here has been working in the software industry for the last 5 years or longer? 10 years? 15? 20? 25? Uh-oh. 30? 30? Yeah, there's someone for 30. Good job. Awesome. I won't tell you what I was doing 30 years ago. So you don't have to have been working 30 years in this industry to know that our world has changed. The software that we're building is different. The people we're building it for are different people. The places we're deploying it to is different. The business models we're using are different. The interaction models we're designing are different. And all of this change means we need to update our tools to work with this. We can't keep using the same tools we were 5, 10, 15, 30 years ago for this new world. You only have to have been watching for less than 5 years to know that Microsoft has changed. We've had a big culture shift. We're more open about stuff. We're more willing to engage with other companies, with other products, willing to have our stuff running on platforms that aren't ours, willing to run platforms that aren't ours, and willing to engage with and contribute to open source software. And the really cool thing is people are noticing about this. Just the other week, I was at PyCon, which is a conference for Python developers filled with people who never use anything that Microsoft makes. And the one thing that everyone kept coming up to me saying, I love the new Microsoft. We've changed so much that we are a new Microsoft. And all of these people who live in the Linux world and never touch Windows have noticed. We've changed, and we're getting things right. What does this mean for you? What does this mean for you guys, our developers, the people who we work with to help you build great software? It means that you're going to get better open source software. We're contributing to products like Python, Node.js, Git, PHP, Firefox to make the open source world better for everyone. You're going to get better open source platforms. We're working with the Linux kernel team. We're working intently in Hyper-V. We're working on Azure to support all of these platforms that previously we would never have given you access to, and now they're here. You get access to these better platforms to work with when you need them. And you'll get better open source tools. The tools that you need to build things are now becoming open source. A lot of the ones that we make are becoming open source. And a lot of the ones that other people have already made open source, we're helping improve. The world you're working in has changed, but Microsoft is coming too. Now, this isn't a keynote. Let's get back down to earth. This session today, I'm going to be talking specifically about Python and Node.js and how they fit into the Visual Studio world and the Azure world. I'm not going to get into too much detail on all of the other exciting places they fit. If you run into the guys who talk about Nano Server, talk to them about Python and Node. If you run into the IoT guys, talk to them about Python and Node. Today, I'm sticking to Visual Studio and Azure. But why would we care about these in the first place? What is Node, and why do we care about supporting it? I believe most of you know, but Node.js is JavaScript on top of the V8 engine, pulled out of Chrome. It started about 5, 6 years ago, at the time when that was the best JavaScript engine out there. And it's running on the server. So now we have server-side JavaScript. So it's young, but it has all the heritage of JavaScript, and it has all the future of JavaScript as well. Everything that's being developed for ES6, ES7 is going to make its way into Node. Because it's JavaScript, and it's the same JavaScript that we're using on the client side, there's a huge pool of developers that can now meaningfully contribute to the server side as well. Previously, they may have been restricted to just doing websites. Now, every JavaScript developer can be a full-stack developer. And the really cool thing about Node.js is, and this could only happen in a young language, it's thoroughly asynchronous. The model was designed from the start to force you to think about things asynchronously, to work with callbacks, to never block the CPUs, to minimize resource usage for massively parallel programs. And because it's so thoroughly asynchronous, everything that you use in Node.js fits into this model, and you don't run into compatibility issues, you don't run into problems where some library, some database accessor, some logging library is going to block your request, is going to take up a significant amount of time during which you can't do work. Node ensures that everything you write is going to fit into its model. And so this is why we're really excited about Node and having that running on Azure, because that is the place where you want high or low latency times for high rates of incoming requests. Node.js is perfect. But what about Python? Why do we care about Python? Python is a much older language. It's going on about 25 years now. It makes it older than C#, it's older than Java. But it's still very active. The development team behind Python is very actively working on the newest language features, the newest libraries, and it's not at all a stale language despite having been around for a long time. It's a very popular language for teaching. It's got a nice high-level syntax, but it still has a full object model, a full type system, which makes it great for introductory programming classes and even advanced language design classes, which means that because it's being used for teaching, there's a large pool of developers always moving into the industry who know Python and who know Python first. And it has extensive libraries and support. It's supported by every cloud provider out there, and in most cases it's their #1 language. If you go to Amazon's cloud, if you go to basically anyone's cloud, they're going to be offering you Python first. And it has great libraries and frameworks. Things like Django, things like NumPy, SciPy, whatever you need to do probably exists for Python already, and it's there freely available for you to use. And because we're investing in these, we have Python, Node.js in Visual Studio and on Azure. But let me clarify one thing. This isn't a product announcement. This isn't something that we just came up with over the weekend and thought, hey, let's do Python, let's do Node, take it to Ignite, see what people think. We've been doing this for a while. Python was first integrated into Visual Studio in an extension released by Microsoft in 2010. That's 5 years ago. We've had Python support in Visual Studio. Node.js popped up on Azure for the first time in 2011. So next year, that'll be 5 years of Node.js on Azure. These are not brand new products we're talking about here. These are serious commitments that we've been working with, which means you can take them seriously as well. What does everything you need in Visual Studio mean? All the features you've come to expect are there. You open up Visual Studio, you know that it has a feature set, you know that it has debugging, you know it has profiling, you know it has a project system, version control. And so we're making sure that all of these are here for Python and Node.js. If you're wondering why you haven't seen Python and Node.js in Visual Studio, you fired up 2015 RC last week and wondered why they weren't there, we're a separate extension. We're a free, fully supported, open source extension made by Microsoft, contributions from the community, to be installed into Visual Studio. Question?
Are you going to do questions now or at the end?
I'll take a question now.
So then for IntelliSense, is there going to be ES6 support or with IOJS or anything like that?
So IntelliSense support for Node.js is the question. That is constantly under development, so I would keep up to date with their latest updates whenever they do that. IOJS is, I don't believe is there yet, but I'm actually a couple of weeks behind what they're doing, so it may be there. And the ES6 support is, again, going to be coming in over various updates. Because we're separate extensions, we get to update as often as we like. And especially the team working on Node.js tools, they love to update. So they'll be sending you updates as often as they can to make sure that you've got the latest version of their tools and the best version of their tools. But everything is there. And we throw in a couple of extra things like remote debugging, cross-platform remote debugging, which is starting to show up in Visual Studio for the other languages. Python and Node.js have had it for a long time because that's a really important use case. Package management is there for both. Again, it's starting to appear for the rest of Visual Studio, but we've had it there for much longer because that's what our users need. That's what Python and Node users need, because if you're not using the libraries for those languages, you're missing the point. And when it comes to Azure, again, we don't want to cut you off from any points. If you want to use Python on Azure, you want to use Node.js on Azure, you have full access to everything that's there, everything that's available. Web apps, formerly known as websites, cloud services. If you want to run on bare metal Linux or Windows VMs, that's totally fine. Go right ahead. All the platform services like storage, application insights, DocumentDB have Python and Node libraries available to use those. Everything that's a REST API you can get to because those languages make those really easy. The extra one here is Azure Machine Learning, which has recently been released. I love this service. It came out with Python and R support. There's no .NET support for this. It came out with Python and R. 2 open source languages, and that's all it supports. That's great. I love that. But when should you actually use these? Most of you are here, so you probably already want to use them, but when are you going to use them? When's the right time to pull Python out of your toolbox and start using it? And as with any language decision, as with any choosing which tool to use, there's no right answer. So here are a few points that are going to help you choose when to use one or the other, but there's never a right answer. Python's really good for glue code. When you have a whole lot of other libraries, when you have command line tools, when you have web services, and you don't have a performance bottleneck, Python is a great way to plug those into each other without a lot of developer time being invested. It's highly portable. If there's a chance you need to run this code on more than one platform, and let me tell you, there's a really good chance you have to run this code on more than one platform these days. Python is one of the most portable languages out there. It grew up from Linux. You can't tell using it today. It runs just as well on Windows, and in some cases better on Windows than it does on Linux. And that's without Microsoft investing in the language at all. That community did it themselves. And it has such powerful frameworks and libraries that your developers, you, are going to spend less time working on things because it's already there. It's already written for you, and they're good quality. And some of these frameworks are huge. Some of these frameworks, like Django, like SciPy, have their own conferences. And not just a meetup one evening. They have like 3-4 day long conferences for a library. What about Node.js? As I said, it's ideal. High volume, low latency request handling. If you have anything that looks like that, and you do, Node.js is a great choice. Calling it a glorified proxy is probably a bit underselling it. But at the same time, if you really need a glorified proxy, Node.js is going to do an amazing job. And I'm actually going to demo that later on. We'll build a glorified proxy. But web API layering is definitely something of interest, especially for anyone that already has existing code. If you have an old system that's still running and still managing your employee information and it's 30 years old and no one knows where it came from, and you want to give it a new face, a fresh API, or maybe you just want to add some authentication on top of it, this is where Node.js comes in. Really easy to start handling those requests via Node.js and processing them. Some people will pre-process UI rendering through Node.js and pre-render UI, send that down to people's phones, because that's going to reduce battery usage on the phone. And both of these languages have applications in IoT, Internet of Things. Node.js is especially interesting because it's so low resource, because the threads never block. You never actually stop running, you never spin. It's all controlled by the language. A good implementation on a low-power device can actually suspend the device. And this is seriously cutting power usage in a way that no other language can really compete with without having to rewrite all of your code. This is existing Node.js code. Because of the async model, is going to be able to have far better implementations on low-power devices. I didn't want to talk for too long, so I'm going to stop talking, and we'll get into some code. But before I move on, does anyone have any questions they want to ask? Yes? Sorry, can you say that again?
There's the link between the Node.js and the Entity Framework.
The link between Node.js and Entity Framework. I'm not aware of anything. That would be kind of cool, though. So, I might chat with the Entity Framework guys about that and see if they have any ideas there. Yeah.
Possibly any, or what sort of support's going towards Node and TypeScript sort of tie-ins?
Oh, Node and TypeScript tie-ins. The Node.js community loves TypeScript. I'm not going to demo it, but the Visual Studio integration has all the TypeScript support there for Node. So you can be writing TypeScript code and compiling it, running it, debugging it against Node.js as part of the tools. That's a fully supported case. And in some cases, it actually works better than the plain old Node.js support, which we're inclined. Well, yeah, we're allowed to do that. Yeah.
Tell me a little bit about the code edition of Visual Studio and another section you mentioned.
Visual Studio Code. Very cool product. I'm very excited about that. To be honest, I knew about as much as you guys did at launch. It's a first release. It's a first preview release. Definitely, I've been approached by a number of people about getting Python support into it. There's been discussions on the Node.js side, and they've actually got a decent amount there already. It's going to improve over time. So if you're really excited about Visual Studio Code, and it doesn't have what you want there yet, hold on. It's still under development. We want to get something out there, but it is going to get much better over time. Anything else? All right, let's talk code. So I have 3 demos, and I've tried to make them things that you could do today, things that you could take back to your workplace and do straight away, because they're working into processes, they're working into problems you already have. I didn't want to get up and do really contrived demos. They're probably still really contrived, but I hope they're more realistically contrived. And again, I'm using a particular language for each one. It's the one that I picked. It's not necessarily the best language for it, and it's not saying that you can't do the same thing with a different language completely. Basically, everything I'm showing you today, you can do with Node, you can do with Python, you can do with C#, you can do with VB, you can do with PowerShell. There's no limits on what you can do here, but these are good demos of using Python, using Node.js. And just to prepare people who like to watch me typing, I'm not going to do a huge amount of typing. The code is mostly there, and we'll walk through. I didn't want to get up here and spend a whole lot of time typing for you. So the first one, Azure Management. Here's a scenario. You have an intern whose job, once a week, is to install some software on his machine, download some files, run some processing, get the result, and then uninstall the software because it's only a trial edition and is not meant to be using it, and you don't have enough licenses, or whatever it is. You have some process that every now and then is a manual process. Someone has to run it. Someone has to do it by hand, and it's taking up their time. It's taking up training time. It's taking up documentation. It's something that you'd rather automate and get out of the way. So we have an Azure Service Management API set. There's a Python library, Node.js library, all the other languages. This lets you do things like creating virtual machines on Azure, deprovisioning machines, and basically anything you could do through the portal, you can also do through code. So this demo, I have a stored VHD. I've created a virtual machine, a Windows virtual machine in this case. I've installed some software on it. I've put a basic little web server on it to run some tasks for me. This code is going to reinflate that machine. We'll create a new virtual machine on Azure. We'll create it from that image. It'll start running. We'll run some process through it, which in this case is compiling a bit of code. We'll be able to download the result and then kill the machine. And this can be completely automated to cut out manual intervention. So here's the code. Here we are in Visual Studio. I've blanked out some boilerplate that really doesn't matter for this. But we have imported the Azure Service Management namespace, which has this big collection of classes that you can use for all the sort of processes I was talking about. I'm just going to get all of them. And you can see what I'm going to type because I didn't want to get it wrong because that's embarrassing. This is Visual Studio. I'm not going to spend a lot of time walking you through all the cool things that it does because I assume you've seen them before. Has anyone not seen the cool stuff that Visual Studio does? That's what I thought. I'm not going to waste time showing you all of that. But look, it does it all for Python as well, just like you expect from every other language. So this service management service takes my subscription ID of the subscription that I'm working with and a cert file, certificate file. For Python side, it's got to be in OpenSSL format because that's what Python supports. There's a conversion function that we have in there to help you out if you get a publish settings. That's in the boilerplate. But once you have the OpenSSL format, you can do that. And now I've got a service management service, which lets me do any of these cool things. So the one that I'm going to do is create a hosted service. This is effectively a cloud service. When I make a hosted service, I can put a virtual machine into it. It lets me sort of wrap up production staging environments and control resource ownership. And because I'm a good developer, I've used constants for all of this stuff. And that will make my hosted service. Some of these functions have a lot of parameters, but because this is Python, we don't actually need to pass all the parameters into a single function call. Python has this cool thing called argument splatting, where I can make a dictionary that has all of the parameters, all the values, and then I can just pass in a single value, which also means I can fill up this dictionary by loading from configuration files or generating it on the fly. It doesn't need to be hard-coded into a single call, and it's a really nice, clean syntax, which is why Python is a great language for doing this kind of scripting work that's a bit above and beyond what PowerShell is really, really good at. But it's not quite a full-blown language where you have to declare everything and you've got to check your types at every step. It's much closer to just being able to get something running without a huge amount of effort. So here are some more settings. I've put in endpoints, which we need to configure to be able to get to it over the net. Here's the virtual machine image I've got. I'm actually building a package for Python 2.7. If you're a Python developer, then you know about the pain of installing PYDs on Windows and not having a compiler. You'll appreciate this more than the Node.js people, because this virtual machine that I've got has the compiler installed. It's going to build the package and give me the pre-built one. Now I have this dictionary. Creating the virtual machine deployment is as easy as just passing in the config. So by doing that, I've passed in about 20 parameters all at once. And I haven't had to pass in the parameters. I haven't had to do conditional statements. I've been able to just put things into a dictionary, and now those are the parameters being passed in. And this operation is asynchronous. So I've got to grab the request ID. I'll give it 60 seconds. If it doesn't work after 60 seconds, then I'm going to abort the demo and we'll move on. But every time I've tried this in the past, it's been fine. Just for fun, I'm grabbing the deployment details, and then out of this, we should have a nice, well, that's a filtered list. We have a list of all the information about the deployment. So if you are doing some other sort of management to check all of your current deployments, you can get access to all of them. And you can get the web endpoints, you can connect to them, you can ping them, you can check SSL certificates, whatever you need to do. Everything is there through the API to let you do that from Python in a nice, clean way. I'm just using it to print out the URL. Let's just start this running, because it will take a bit of time. So it's running off to, I should have the portal up, shouldn't I? Hey, let's do that. On the fly demo changes. So this is creating a virtual machine. So I hope I'm allowed to show this portal. You can all get to this one. This is not actually secret. So this is my list of VMs. As this moves forward, here's my output window. So we're provisioning the virtual machine. We've created the hosted service. That's nice and quick. The virtual machine is being provisioned. That takes a little bit longer, but we have this nice dot progress going on. The the portal is actually a couple of minutes behind what's really going on. So I can get more current information out of the SDKs than out of the portal itself. Another good argument for using code for this stuff. Once the provisioning is complete, we've got a virtual machine, it's started running. Now it's a Windows image, it's going to take a little bit of time to start up and actually get running. So I have an extra loop in there that's actually just pinging it's pinging one of the endpoints on the machine. It's expecting basically a GET request to succeed. And when that succeeds, you know what? I think it might have hit the timeout. So we've hit the timeout, and apparently I'm not going to finish this demo today. Like I said, it's worked every other time I've done it. It worked at Build last week, so you can check out the video from that if you want to see it succeed. But what we were going to see from there is the machine would spin up. We have access to a public website, which is something that I just left running on the machine when I captured the image. And that lets us trigger an operation. It would do some processing and give us a result file that we could download. And then, as we come down here to the end of the file, we delete the deployment. Again, wait for it to go away. And now that means that the virtual machine is not costing us any money because we've actually gotten rid of it. Everything I've shown you up until this point has been free. This virtual machine is the first thing that's actually cost you any money at all. And so I'm showing you how to get rid of it nice and quick, because that's how you minimize the amount of money it's going to cost. Now, why is this really important? Okay, I'll be honest. It's like the virtual machine is how we get money out of people. So if you want to leave it running and keep paying us for it, go right ahead. But if you want to save yourself some money, and you do, then you get rid of the machine. Some of the virtual machines we have are actually really beefy. Really beefy. You can get a machine that has, 32 cores, 400 and something gig of RAM, and like 5 terabytes of SSD space. That machine's going to cost you a lot. On the other hand, it's going to get its work done really quick. So if you have something that's really processor intensive that you do once a month, this is a great way to set up a script that will give you that machine, run your process, get rid of the machine, and it's cost you a couple of dollars. You haven't had to have $20,000 worth of hardware sitting in your own lab, and you haven't had to keep a machine around the whole time, and it's automated. As I said, you can do this with any language. It doesn't have to be Python. Python is my choice here because it's a simple language. It's going to make it really clear what you're doing, what the code is writing, and it's easy for someone else to come in and maintain. Does anyone want to ask anything about that demo? Sorry it didn't succeed. Always a risk. Okay, the next one does not depend on Azure, so this one's going to work fine. Oh, can we cut that out of the recording? I might get in trouble for that. It's a conference. I mean, we expect this. I also didn't have time to move the image from West US to East US. I don't know how much that hurt, but that might have had something to do with it. So, in this demo, I'm going to set up effectively the glorified proxy in Node.js. The scenario here is we have, again, an old system, 20, 30-year-old mainframe system that is tracking all of our employees and how much they get paid and whatever details we need about that. But we want to make it available through a new app, maybe a mobile app. And the API that this server has is not really sufficient for that. It's giving us XML. It's giving us a lot of XML. It's really bloated. It has dates in an awkward format for anyone who's not an American. And it has no authentication. So this is all stuff that we want to add so we can let our employees, we can let our HR department, finance, whoever it is, access it from their phones wherever they happen to be. Rather than go in and change all of that old code, I'm going to write a short Node.js application. I say write. I'm going to copy-paste a short Node.js application from a separate file because I'm not going to type in front of you. That will forward requests to the old API. Because it's going to be in the same data center, possibly the same machine as this old system, it can go to the old slow API. It doesn't matter that we're sending far too much XML across because it's right there. It's going to convert that to JSON. It'll reprocess to JSON, and send down just the information for the request that's needed, which gives you something that a client-side app, a single-page web app, can easily get and process and use to display on the phone or on whatever device they're using. Now, the old application with the XML API, I've just written in Python because it was nice and quick. So I'll start running, and let's have a look at what this has. So the data that's giving is this kind of XML file. And you'll notice a delay there when we try and go to it. It's a slow machine. It's a slow system. We don't want to spend that much time on every single request going to our users. But this is what we have to work with. I'm working here in a cloud service project, mainly just to show off that Python and Node.js support cloud service projects. So if you're working with cloud services, in Visual Studio, you can continue to do that, and it's one of the most flexible ways to be using these languages right now, because you have the complete freedom of installing whatever you need on the remote machine and really controlling it from start to finish. For our web API, I'm going to add a new web project, a new web role. And in this case, it's going to be just a plain old Node.js web role. This gives me the Node.js hello world. A lot of you are familiar with this. And I don't actually want it. So the first thing I'm going to do is copy over some of my extra requirements that I'm going to need and make sure that these are available. I'm grabbing in a couple of libraries. The URL one is obviously built in. PathMatch is a separate library. It's handy for routing. It just makes it really easy to process paths and to grab variables out of them and pass them and be able to access those nice and easily. So in this case, we're going to have a route called user that takes the ID, where that ID is just put straight in line. There was just like the ones down the bottom there, which don't work yet, but they will soon. So when we come in to this server, this is a callback function. This will be called on every incoming request. We haven't done the filtering yet. This is where we do it. There are plenty of frameworks for Node.js that will make this easier, make doing huge projects more manageable. This is a really small one, and so I wanted to stick closer to the hello world rather than using something like Express or one of the big frameworks for doing this kind of stuff. So this is a pretty low-level way of doing this kind of thing. But I like low level. So from the URL module, I'm going to parse the request that's just come in and grab the path name out of it. That path name is everything from the slash onwards, and it's going to exclude query strings. This is why you didn't want me typing lots. So what we have here is we're calling into some of these constants from above. We created a user summary route. We're going to call that, and when we call that, so that's generated a function. When we call that, pass in the path, it's going to see if it matches. It'll pull out the parameters that are in there. And so then we can call, and then we can use params.id, which is going to be the ID segment out of that URL. I've defined a home one, just for the sake of showing something at the home. Anything else, we're going to respond 404 because we don't have a handler for that path. It doesn't exist. And most of the work here is going into this getUserInfo function, which I have not written yet. Node.js is thoroughly asynchronous, which means when you write a function like this, rather than returning a useful value, depending on how complicated the function is, you may need a callback. In this case, I've defined a callback called callback, and we can see that it's a function that needs to be passed status and data. We know that because I've already used it down below and provided a function here that takes status and data. We're not magic, but we will read all of your code And so anything you could figure out from reading all of your code, we'll do it automatically and give you that information. When your project starts getting big, this is a huge help for tracking down where things have come from or what things need to do. So inside getUserInfo, I'm just going to pass in a request to the old API. You may do some more complicated caching here, depending on just how slow it is. But in this case, it's going to be local. I can deal with a huge amount of data. And so I'll just pass in a request. And I'm just passing in the ID that I got before, basically translating the API to the old path. This response has a status code, and if it's not success, then we want to get out straight away. I don't have to pass in the second parameter. All arguments are optional in JavaScript. But I do want to return, so the rest of the function is not going to be executed. I'm going to use two more libraries here, the XML DOM library and XPath, because this is a code you really don't want to see me typing out. Okay, a lot going on here. We have a response come back from an HTTP GET. That has a couple of events to deal with. On data events, we need to accumulate the data, because that's going to be called a number of times. And so we just want to keep concatenating that to make sure we have the entire response. Second event is end, which is going to be called once when we've got all the data. And so at this point, this output variable we can use, and we can parse the XML. So using XML DOM, we're going to parse that response, and then use XPath, and we're just going to make this big expando object that has all of the properties that we care about on the user. This is what's going to be serialized to JSON and sent back. So if I come down to that one's wrong. If I come back down to where we call back, data is the response, and we're just going to stringify that and return that as the response. So it's a fairly simple transformation. Using XPath, which some people may dispute they're fairly simple, but it works, and it works fine. We're even going to sort the items by date. Before I can run this, though, I need to add some dependencies in. So I haven't actually installed all of these libraries I've been using. We have a couple of ways of doing it, but I'm just going to copy in the dependencies into the package.json. And you'll notice as soon as I do that, we suddenly have these 3 dependencies pop up here, and they're all missing. So I can right-click the NPM node, install missing NPM packages, all going well. We'll now have 3 packages installed. So now the packages are there. If I come back into my JavaScript code, the require call is going to start showing up things like XML DOM, XPath, path match is there now. And we'll give you that completion and completions for everything inside them. So now I run this, and we're into the new API. So that's the first route that we created there. And I can swing back over here, and we'll pop open the new fancy JSON API, and there we go. Slight delay, but we've taken the old XML and wrapped it up into JSON. Now, one thing I'm personally still not happy with here, because for those that haven't noticed, I'm not from the United States. And so I look at some of these dates, and I get really confused. Because these are probably month, day, year style dates. But for me, I'm used to day, month, year. So I'm looking at this saying, oh, this is the 3rd of July. And this is the 2nd of December, which hasn't happened yet. So I want to fix this. JavaScript has a date format. It serializes nicely. It's unambiguous. So let's take these dates. Let's parse them into that proper format, and we'll send those back in the JSON instead. To do this, I'm going to take the part where we set the date. So we're grabbing the date out of the XML. I'm going to wrap it up in a fixed date function. This function is not going to be asynchronous because it's really short and it doesn't actually call out into anything else. So inside fixed date, we already know that S is coming in as a string. We can see all the completions there for that. As soon as you call a function, we can flow that information through. This is not the nicest way to do parsing, but it's an old system. I know the format is not going to change. So I'll split, I'll reorder. Let's turn that 2-date year into a 4-date year. And now I'm actually just passing strings into the date constructor. JavaScript will happily do the conversion to numbers, assuming they can be converted to numbers. It will not so happily not do the conversion if they're not numbers. And that will give me back a date. And so with that change, let me set a couple of breakpoints and let's step through this. With that change, we'll start getting APIs that have properly formatted dates. So we'll hit refresh on the page I was on before, and now we've broken into Visual Studio. We're at the top of this function. We're about to do the get for user 101, as we know. And now we've jumped all the way ahead to the point where we've finished. We've got all the data. I can have a look at output, which is here. Again, it's Visual Studio. I can pull open the visualizer and visualize the XML if that's how I want to view it. And I just stepped over user. So now user is defined, and we can expand that and see all of the information about user in the form of a JavaScript object. And in this case, the date is a proper date now. As we step through into the stringify, I should be able to see that in data now. Now we have the JSON. And you can see I've actually just stepped into the HTTP module here, which is not part of my code, but we'll happily let you do that. And I can visualize the JSON file that we've generated that we're sending back, and we can see that we have, well, this is dates formatted with my formatting, which I think is because that's how Visual Studio does it. But we can also search for this and track down any information in the JSON that we want. This is a neat way to visualize things that are just blank strings otherwise. So now we've refreshed and we have an actual ISO format date here, which is unambiguous. So we have a much nicer API as a result of doing this, not a huge amount of code, and a lot more flexibility to make changes, to maintain this code, to add in the authentication we need, to add in any extra validation or new business logic into this layer, rather than having to go mess about with our old system. Does anyone want to ask anything about that or have me? Yes?
Node is single-threaded, and your output variable is being added to each time, so it wouldn't be safe for that to not be single-threaded, but is there any way to use all the cores on the server?
So the question is Node is single-threaded. It runs everything on a single thread. How do you go about making use of all the cores on your server all at once? There's a number of ways. The simplest way is probably just to run Node multiple times. That's got its own complexities as far as multiplexing and load balancing within a server. I believe there are actually tools that will help you do that, though I haven't used them myself, I'll be honest. Within Node itself, there is, so this particular case that I've highlighted here is going to be safe regardless, because even if you were running multiple threads, they're not going to be, the closure is going to be for different variables. So if you have different requests coming in, then they'll be closed over different values for output, and they'll be concatenating with something else. I would hope. It's entirely possible that that's not the case, and that's why you can't do it. But certainly Node is one of these, is a tool that works great single-threaded, doesn't necessarily need multiple cores to work well, and does need some form of load balancing. If you are interested in making use of Node on a lot more powerfully on a big server, chat to the NanoServer guys. I believe they have Node running on NanoServer, or at least they're working towards it. And that gives you full machine isolation in a much smaller package that could be far more powerful there than simply running multiple instances of Node. Any other questions? Yeah. Is the chunking, the chunking here is native. This is part of the HTTP module. So if you do, I will openly admit, I may not have written this the best way. Don't take this as an example of perfect JavaScript, please. It's not my native language. But I believe that this is the correct way to handle HTTP GET from the HTTP module. There may be other modules that will do GETs that don't require you to do this. I'll do the chunking for you, or they'll just give you the response all at once. At the lowest level, the built-in module, this is how to get the full response. And it's very likely, I haven't checked, that we're just getting one chunk back anyway, and it's not actually being split up at all. Anything else? Okay. So I have one more demo. And this one is more about the Visual Studio support that we have and how that may be immediately useful to you if you're already using Python or you're using Node.js. So we support cross-platform remote debugging. The scenario here, you have some process, you have some script, it's Python, Node.js, whatever it is, that has to be running on a different machine. It's got to be running on Linux for whatever reason. It has to be running, maybe it's running on Mac OS so you can do testing over there. And something is not working right. And you want to stay in Visual Studio, which normally does not work out so well. Hopefully Visual Studio Code fills this gap eventually, so you just jump over to that machine. But if it's a completely headless machine and you still need to debug the code that's on there, we have ways to do that for both Python and Node.js. This demo, I'll show it with Python. It's fairly similar for Node. The instructions are on the website that I'll be linking to a little later on. So I have a script running on a Linux machine. It doesn't need to be running on a Linux machine. It's using a Python library that I haven't installed on my laptop. So that's why it's on the Linux machine. The Linux machine is on Azure. It's a real remote machine. This is another demo that may not work, but it looks okay so far. So let's see. And that script is taking some of my holiday photos from the last time I went home, and it's generating thumbnails for them. So I have a storage account on Azure filled up with all of my raw photos. It's going to run through that blob container, grab each blob in turn, resize the image, do a little bit of enhancement, and then save it as a thumbnail. This script is actually working perfectly fine. I tried to come up with a good example of something that was wrong and decided it's going to be just as fun to step through it anyway, so we'll do that. So here is the machine. It's in PuTTY. I can't prove to you any other way that it's not actually running locally. I don't have Hyper-V going on this thing. But this is, in fact, running on Azure. And I have a script here called demo. And in fact, let's just... This is my script. So this is basic editing. Obviously, if I jump over to Visual Studio, I can have a full editing experience. And so I'll come back here in a second. But right now, I'm just going to start running that. And we'll see that it's going off and grabbing blobs out of a container. And it's generating images, or it's displaying the URL for the image and generating a thumbnail for it. These are public URLs. So if you're quick, you can type these into your phone and you'll be able to see them right now. But I'm going to copy some and show you anyway. So here's one of my photos. Obviously, I went home to Melbourne. So that's a Melbourne tram. And the thumbnail that we've generated for that has gone into a separate container in the same account. There it is. Nice big thumbnail. Smaller thumbnail when I'm not zoomed in. And so this is what the script is doing. We're taking a whole lot of images and doing the processing, to generate these. Now, this could be any sort of process that happens to have to be on a certain machine. Like I say, it could be running on the one Mac machine that you have handy for whatever testing you do on a Mac. It could be some very Linux-specific software. It might be something that you picked up from another company that doesn't run on Windows, and yet you need to be running it. For whatever reason, you have this code on a separate platform. But remote debugging works just fine on Windows as well, so maybe it's just a separate Windows machine. We do have entry points for remotely debugging software running on Azure websites, Azure web apps. We have a nice little right-click in Server Explorer and let you attach straight to those websites from there. So it works just fine on Windows as well. The cool thing is that it works well on Linux and Mac OS as well. And this is the code. As we can see, I have a library that's not installed here because I haven't installed Pill. I could. It's fairly easy, but I haven't, so that's why it's not going to work locally. I'm using the Azure Storage library and specifically Blob service for managing resources. There's a bit of boilerplate there for getting things set up, but here we're simply listing the blobs in the source container, and for each one of these we're going to read the blob and open it as an image. The steps from here, fairly straightforward. We grab the size, we'll get the smaller edge and we'll do a crop. Run edge enhancement because I thought that might make it look better. It doesn't really, but we can do edge enhancement. And then, well, in fact, maybe it'll work better if I put it after. Let's try that. Okay, now we're running edge enhancement after we resize down to a thumbnail size. And then we're just going to save it back in memory, into Bytes.io, and then we'll put the blob from those bytes back onto Azure. And we can grab the blob URL simply by calling the blob service for it. So it's fairly straightforward code. Now, how do I make this debuggable? You could do this locally and redeploy the code, which is what I'm going to do, or you could do this remotely and do it through Nano or Xcode or whatever editor you're going to use for Python code remotely. But I'm going to import this PTVSD library. This is a library that we wrote, that we published. It's on the Python package index. I forget the name of the equivalent one for Node tools. It's probably NTVSD, but that slips my mind right now. But when we import this, this has only a few functions, but one is to enable attach. By default, you don't want your code to be attachable for debugging. Firstly, it's going to reduce performance slightly, because as soon as you do this, we start tracking some information about threads, about call stacks, because otherwise when you do start debugging, you'll have no useful information at all. But the other thing is it's a security hole. You've just opened up an endpoint on your server and said, hey, connect to my code and mess about with my running program. So you want to protect that. One way you can protect that is with a secret, which I'm not using a very good one. You should use a better one. Or you can set up SSL certificates, and that's going to do a validation to make sure the right person who's connecting is allowed to connect. Next thing I'm going to do is wait for attach. So by adding that, the process will start running and then stop, and it's going to sit here at the start until I actually connect, and then it will keep running. Without that, the process, I'd be interrupting the process at some point, which is fine, but in this case, I want it to stop right at the start. And that's the only change I need to make. So from here, I can get rid of that. I'm going to open a command prompt and run my little upload script.
Install anything for PTVSD on the server?
One step ahead of me. And now I jump back to the server, and I install PTVSD over here, because this is where we need to have that library installed. The -- pre in this case is because I'm actually using a pre-release version of Python Tools for Visual Studio. I'm using the RC that we released last week, which has an equal pre-release PTVSD that you need to be using. So the -- pre will get the correct version, which in this case is still labeled beta because we didn't actually change it since beta. But now PTVSD is installed, and I can run my demo script again. And this time, it's not going to start processing stuff because it's waiting for me to attach. And yes, now I do have a security hole on this machine. So if anyone's really quick and they're trying to connect to it before I do, you could spoil this demo. Please don't. To attach to the process, it's the same as attaching to any other process. Debug, attach to process. We have a drop-down here for Python remote debugging. There's a few different ways we'll let you connect. There's a similar one for Node.js as well. I'm simply using TCP in this case. There is support for WebSockets, which requires a proxy on the other end. It requires a WebSocket proxy. So if you'd rather use WebSockets, it's possible to set it up. And I realized as soon as I said it, we don't have good documentation on that. So if you want help setting up a WebSocket proxy to do this, come to our GitHub page and get in touch with us, and someone from the team will help you set up WebSocket connection. But TCP is just fine for this, and I can admit it because it's the default. I put in the secret at the URL of the machine that I'm on, hit find, and now we'll see a list of all the running processes, Python processes on that machine. One step that I didn't mention is I did open up a public endpoint to that machine for the port that I'm using. So if you don't do that, you're not going to be able to connect. Yeah. But that's one step that I left out. So 5678 is the port that I opened up, and hopefully now that I'm attached, no one else will be able to. And the process will start running at this point, and we've hit a breakpoint. Question? This works with Python 2 and Python 3. It will also work with alternative implementations such as IronPython. Should work with Jython. We haven't tested that recently. It works with PyPy. It is pure Python code that is compatible with, as far as we know, all the versions that people care about. So it will quite happily work wherever you need it to run. And we can see here now that we're in Visual Studio, we have the full debugging experience. The Autos window is full of values. I can expand the blob client out and have a look. I can expand this source object. We can see all the properties for the value for the blob that I'm looking at, and all of these are being pulled down from the server right now. As I step through, the Autos list is obviously going to update and show us different things as we go. And now I've opened up the image, so I can expand this image out and see all the details about the image that I've just loaded. Normal stepping applies. If I hit F5, we're going to run around the loop, and we'll come back to the start again. And you can see the output is being displayed here in the window because we're sending that back. So there's actually no need to even log into the remote machine and be watching what's going on there. We have this data coming back here. I think I like the edge enhancement being after. But here's one of the cool things that you can do here. If you actually need to execute code in that remote process, we have a way to do that as well. Under Debug, Windows, and Python Debug Interactive. Now I'm in an interactive session in my running process, so I can access, let's step through a little bit. So I can access all of the local variables that are here in this context. I can get completions for everything that I've opened, all the variables that are here. And as I step through, I should be able to do $S as well to step, so I can step from the Debug Interactive. Anyone who's been doing this for a long time may remember some of the command line debuggers that we used to use before Visual Studio came along and saved us from them. You can go back to that if you like. We make that available. And what I'm actually going to do here is I'm going to grab some code. I'm going to grab this bit of code that saves the thumbnail. And just to prove that this is really working, I'm going to start running this more regularly. I'm going to run this early. So let's just cut back the indent. And so now I've just gone ahead and saved that thumbnail early. So this is after we've cropped and before we've resized the image. And that image is make blob URL has come from target container. So this is the thumbnail, which is not quite a thumbnail yet because it hasn't been resized, but we have cropped it. So when I open it up over here, we'll see that it's already cropped to a square shape. If I step over the resize, and now I can run this block of code again, I just hit the up arrow twice to get there. And now we've resized the image. I can step one more time, and now we're in fact at the end of it, so I can just step over the regular code, and we've done the enhancement on the image. And every time I'm dumping an image to the public internet from within Python code running on a Linux machine, you can see all the same output showing up over here. Here's how I can do proof. Print hello ignite. There we go. Executing arbitrary code in our running process on a Linux machine on the internet from Visual Studio. Does anyone have any questions about that? Yes?
Assuming any node process or any sort of like node server would go down while you're doing the development.
Yeah, if you're debugging a web server, that's going to make that server not very responsive. That's generally how debugging works. If you need to debug a server, you better hope it's not live anyway. Debug in staging. Okay, this is where you pull out your phones and take pictures. These are the links that you need to have. aka.ms/ptvs is the Python Tools for Visual Studio landing page. NTVS is the Node.js Tools for Visual Studio landing page. That last one there, if you're not sick of hearing me speak, we recently put up an introductory video series for using Python tools and getting set up, so there's another 15 minutes or so of me speaking there. These are the official landing pages. The unofficial landing pages are on GitHub. So if you go to GitHub and look at the Microsoft org, you'll be able to find Python tools for Visual Studio there, Node.js tools, as well as all the other open source stuff that we're doing. So come and contribute, report bugs there, start a discussion. That's monitored by us, by the developers, by the engineers. We're not passing that off to anyone else yet. So to wrap up, our world has changed, and the tools that we need to use have changed as well. You can't get away with a single tool to do everything. You need a toolbox. It's full of tools. Node, JS, and Python are powerful, flexible tools to put into that toolbox. So you can use the right tool for whatever job you need to be doing. The world's changed. We have to go cross-platform now. Everyone is cross-platform. Whether they're going to like it or not, you can prepare for that. Now is the time to avoid locking yourself into any one platform as much as you possibly can. Python, Node.js, a lot of open source tools are very portable between platforms, and they're going to avoid having you locked into places. And finally, open source is absolutely worth embracing. It's taken Microsoft a long time to come around to this point. If you've been following us, then you know that things have changed with Microsoft for this. Tools like Node.js and Python would not exist if it weren't for the open source community. Some knowledge of software engineering these days is not in conferences, it's not in books, it's in open source software. It's in the code that's out there for everyone to see and use. So if you're working in code, don't just be aware of open source. Definitely don't be scared of open source. Use it. Build on it, add to it, contribute to it, improve it, share it, and please embrace it.